welcome all. Yes, this is a talk on observability. But it's more than that. Because it's also about sustainability. So, I've been speaking about this for a while. It's a passion of mine, so both observability and also applying those things to build a more sustainable world. And let's see why that is. But first, I have to introduce myself. This is me, so it's proof, right? My name is Mark van der Walle, and I work for a company called Society. It's slightly hidden by the banner, but that's fine. So I'm a lead software architect and Society Labs fellow, which basically means I'm allowed to write blogs. Right? I do this mostly in Java. That's my main language, or where I originated from. It's not that I develop that much, well, not daily anymore. Preferably a bit cloud native, so microservices, containers, Kubernetes. We'll get to Kubernetes later on, which is going to be fun. And obviously, observability, because I think that you can't do any cloud-native development with observability. But this is not just an observability talk. This is about climate change, and we need to talk about the role of IT in climate change. And especially if we're talking about energy consumption. So, all these numbers are depending a bit on which reports, which year, etc. But as IT, we would be roughly the third largest consumer of electricity if you would view IT as a country. So that's quite a lot. And with the rise of AI, this is spiraling, and not down, up. If you then look at global emissions, IT accounts for roughly 3%. And again, this is depending on your reports, and that's bigger than Spain, Italy, France, and Portugal combined. Well, this is if you're looking at direct emissions. If you look at scope 2 and 3, and depending on the country you're in, these numbers can grow above 6 till even 8%. So IT is big, and it's actually larger than aviation, which is a bit unfair, by the way, just talking about aviation, because they don't measure carbon above certain levels. So yeah, that's a bit annoying. So yeah, don't trust the numbers, but it is big. So there is something that we need to do. So talking about energy consumption, you would assume that if we then say, let's put, other way, that's annoying. Doesn't, there it goes. Yeah, put everything on renewables. And then we're fine, right? Well, there's way more to it than that. And let's first look at energy supply. Let's look at the energy mix. If you look at renewables, this is roughly until 2022, but it's not, hasn't changed that much, might be slightly bigger. But if you look at the renewables, modern biofuels, solar, wind, hydropower, nuclear, which is actually pretty, well, relatively green, right? Even though it has waste. But most of it still comes from natural gases, oil, and coal. So thinking we can put everything on renewables is just, wishful thinking. So we need to do something else. And then we get to an interesting problem. Because we as an industry are not that good with our resources. We mostly do something like this. Well, excluding the goat, perhaps. Yeah, so we're very much wasteful with what we're doing. And that comes a bit from this part. Yeah, cloud and cloud consumption give us sort of, well, unlimited nearly unlimited resources. The size of your credit card is what mostly describes the amount of cloud that you can get. And not, well, it's almost unlimited. If you look at cloud consumption worldwide and just looking in virtual machines, so I have to look at the numbers because these are tricky. So in 2022, the cloud spend, global cloud spend was almost 500 billion. And then you get something interesting. Roughly 28% of that went to resources that were not used or hardly used, so less than 5%. So that's 21% of that almost 500 billion worldwide. And that's cloud spend. Yeah? So we're not talking about your traditional on-premise data center because these are a lot harder to measure. So it might be even worse there. So if we look at 2023, cloud spend went to 600 billion. But the waste grew to 28%. So we spend more, and we're also doing it more crappy. Can't say anything else. So in 2024, it's expected to rise even more and more. And, well, what that will do with our waste, I hope we're doing better. And the world is learning. So, no, our spend is not only on Gen AI, it's not only cryptocurrency, we're spending it on stuff we don't use. That's one part of it. The other part is that it's hard to see. I mean, we're using IT right now, right? So my laptop is very visible. But that this presentation is stored on OneDrive, yeah, that's somewhere in the cloud. It's also on my laptop, obviously. You don't see it. You don't see that you're consuming energy all the time. And if that's green or dirty or what it is, we don't know. So that's a big part of it. It's invisible. It's always there, but it's invisible. And another part of it is, I promised to start doing this, making fun of Kubernetes. Nah. Who is using Kubernetes, OpenShift, or any of the, see, a lot of people. How many of you have actually look at your requests and limits a lot? Very nice. Why? Is that because you want better performance, so you're looking at the throttling, or you want to reduce costs or other stuff? Probably, most of the time, we're not that good in sizing that. So perhaps we give it, let's say, some extra memory, some extra CPU, because then at least it doesn't crash and at least gives us good performance. So we tend to give it way more resources than necessary. I'm not saying that Kubernetes is the problem. It actually can help you. It has a lot of tools to help you there as well. So again, this is not specific the problem, but it doesn't help either. And then we come into something that I like a lot. If you can't measure it, you can't manage it, said Peter Drucker a century ago or something, long time ago. If you can't measure it, you cannot improve it. Lord Kelvin, or William Thomson, the guy from the Kelvin temperature. You can't manage what you don't measure. W. Edwards Deming. So a lot of people said this ages ago, and they weren't talking about sustainability, obviously. But it's similar, right? So if you don't see it, if it's invisible, you can't do something with it. So you need something in place. And that's where observability comes in. Yeah? Make it visible. Make our systems visible. So what is observability? Well, I'm not going to read this out loud, but there's some emphasis on it. Measure, analyze, insight, complex system, behaviors, understanding internal working. So this is about diagnosing problems. Observability can also be used for that, also on costs and other things. So who said this? Obviously, in this day and age, you have to ask ChatGPT. So actually, I did this last year somewhere. So probably I get a different answer now. So we need to make things visible, right? So again, let's recap on what observability is. So on one hand, we have logs, we have metrics, and we have traces. And those are the three pillars of observability. Observability. So that's what we need. But how and why? Well, we know about the why. Let's talk about the how. But there is another beauty for observability, because my origin is a Java developer. But observability is not just Java. It is your database. It's your big server, whether it's physical or whether it's virtual. It's Angular. You can put observability in your Angular. There's actually a talk about front-end sustainability later on. You can do it in your Android. It can be in C#. And yes, it can also be in a Java application. So it doesn't limit you to any stack. With the open telemetry movement, there's a lot more that you can do just out of the box. You don't have to build that much things. And then now you're asking me probably, how? What should we look out for? There is a problem with observability, or not just observability, because there is one thing: it is hard to measure carbon. So my laptop is now using that much. It's probably getting some power. I don't know where it's coming from, right? So it's coming from somewhere from the wall socket. We're not sure if that's clean or dirty energy right now. It is possible to make a model, so that's something we can do, but we need a proxy or something different that we're looking at that we can either map onto a model of carbon or use that proxy as a measurement. So let's look at the proxies that we can use. So the first one is cost. If you think about cloud economics, so actually reducing your cost. I was talking about waste earlier. If we would reduce our cloud spend by 10%, and then we still have a lot of waste, probably, well, actually, not probably, most definitely, we would also consume less energy. And if you consume less energy, you're also reducing your carbon emissions. It's very easy. And that has mostly to do with cost in clouds. The other one is energy. If you can do this, I mean, this is not always easy. Fortunately, there is a lot of movement in this space. So the easiest one is to actually put something in the wall socket. Physical. Yes, but that's hard to do. You can't drive up to your Azure, AWS, or Google data center and, hey, can I put a wall socket measurement somewhere in between your server and the wall? You can do this on physical stuff. You could do that here. There is other stuff like the REPL framework that makes it already a bit easier. So you can ask your CPU, hey, how much energy are you using? Intel is very big on that. And if you're I saw a lot of people who are on Kubernetes. There is the Kepler project, which also uses REPL. And then you can actually see, hey, this workload is using this much energy. That is something that you can put in your dashboards, right? Look at it over time. But there is more that you can look at. because this is still, this needs a lot already, and the same with cost. Utilization. And this has to do with looking at how am I using my resources. So I claim a virtual machine or a physical machine, or I request resources on my Kubernetes cluster, but am I actually using those? And that is something I think is the easiest for us all to apply, because we're probably measuring this already. We just need to figure out, are we using it right? Are we actually using it in the right way? So I have an example of, obviously, Kubernetes, where this went way wrong. So this is, cores used, requests, limits, actual used, what has been requested, and what people put in the limits for CPU. So I actually hovered over a period in time, doesn't really matter, to actually emphasize the amount. So all the workloads in a specific environment requested 148 cores. At that moment in time, 10.7 was used. Ridiculously amount of waste. And if you look at the graph, up till, no, I think it's 8 or 6 o'clock at the end, something. Let's say that it might have gone till 20. I mean, don't know exactly. So 20 cores used on a typical day, while the requests have been 148. And similar with memory, so the percentage used from the requests is, it's not that bad, but if you look at, so someone made a typo there, I see. But so what's been requested, the limit, and what's actually being used. And this, I think, well, I'm not saying that this is the problem of Kubernetes, but I see this a lot. And if you make it visible, I showed this to the client quite a while back, and I was saying, hey, if you're not doing it for sustainability, please do it for the costs, because this is a ridiculous amount of waste. So if you make this visible, and this is fairly easy, right? This is the dashboard that you can make in let's say 10 minutes, because you're probably measuring this in your Kubernetes cluster as well. If you do this in Azure, there is also insights. If you have cloud economics, and then look at it with a green lens. But there's also other stuff that you need to look at if you use observability. So we'll probably all know about this right now. They are getting quite big, the Green Software Foundation, and they came up with these three. So the middle is the most tricky for us as developers or software architects to deal with. If you're an IT architect and you're actually buying or need to make buy choices for your hardware, then hardware efficiency is something that you can talk about. So if you have a server, usually you say, oh, its lifetime is 4 years. If we can extend that with with 1 extra year, yeah, then the amount of carbon is spread over an extra year. Yeah, sort of. It's the same with economic value. If you look at carbon awareness, that's something as developers we might be able to do something with. For example, right now it's not that sunny, but yesterday it was quite sunny, depending on where you were at. If you have solar panels, you put your dishwasher, your laundry, you put it on during the day, right? We used to do that during the night because energy was cheaper. Now you do it during the day because then you're using your own energy. The same principles apply with IT workloads, but it's not always easy to do because you would like to say, for example, yeah, I'm going to do the job that I would normally do at night. I try to run that in a country where it's day at that moment, so you're using less dirty energy. Depending on the data that you're using, you can't do that. GDPR, things like that. But it might be tricky. You might also say, I'm doing it a bit slower, so we're using less energy. So there's things you can talk about, so be aware of the green dirty mix and where you're putting your workloads and how fast. If you look at energy efficiency, so consume the least amount of electricity possible, I think that's where most of us can do the most of work. Because it is, well, one part is the waste, so just don't waste stuff. But also, and that's something people are always a bit afraid to hear, we build crappy software. This is a famous problem. I just Googled for this, N+1 problem, observability. So, especially if you in the Java world, you have JPA, N+1 is quite famous. It's also easy to fix, but if you don't see it, it just happens. So one query triggers all the child queries, and this goes on for a while. And if you notice, so all these queries are quite fast. So the initial query is 29 milliseconds, and the others are even faster. But there are so many of them that this entire request takes 22.4 seconds. So this will probably go way down in the basement and even further. And you make this visible by such simple tooling as tracing. I mean, this is becoming so commonplace. And the thing is, if you rewrite this query or change this, how you configure your JPA relationship, if you're using Java, you're not only using less resources, because all these queries are going back and forth to your database, and well, costing some CPU, some memory, etc. The total query will probably be a bit longer, so longer than the 29 milliseconds, but not as long as the 22.4. So you're not only using less resources, it becomes way faster. So that means that your user is also more happy. So doing sustainable stuff is actually something good, also for your credit card bill and for your user experience. At least if you start building less crappy software. This is the best example I have of building crappy software. But we do it all the time. So a good example is, I'll always call this select star from database, only use a tiny portion of the result. So why do we do this? For example, you have an existing code base, and then you say, hey, there's already a method for retrieving what I want, even though there's 90% of what you want, you don't even, or what's coming from out of there, you don't need it, you don't use it. Request data every page load / user request. The data never changes or hardly changes. Good example for that is tax rates. You have an order service, and that order service needs to calculate something with tax, and you have a sort of service that delivers that rate for you. And every order you say, hey, what's the tax rate? Well, it's 21%. The next request, what's the tax rate? It's 21%. That tax rate doesn't change every 5 minutes. It probably changes, well, even if you would cache that for a month, that would be, already too long, but it's better than doing it every request. And your 25 megabyte auto-playing video on your homepage, on your website. This is not something we as developers build, but marketing departments do. And we as developers are sort of in charge of getting that running. Don't do this. Especially not the auto-playing, but also not the 25 megabytes. It's ridiculous. And unfortunately, my company doesn't do any better. I checked, and I told them, please don't do this. But yeah. And you only get people to change this if you make it visible, right? So, making this visible is the only way, or for me it's the only way of getting people to change. So if you don't put it in front of their faces, like, hey, this is really silly, this is wasteful, this is costing you tons of money, and this is actually bad for our Earth. And sometimes even user experience, as I mentioned. So there is a big win of that. Clicky, clicky. So observability is what I started with. And I call it a catalyst, right? Because it is not the solution in itself, but it triggers people. If you make it visible, it's the same if you show them the error rate. And then they say, why do we have so many errors? Well, it's the same as before, but now it's visible, and then you tend to do something about it. If you're constantly seeing, I'm using that much energy, or if you're driving in your car, you constantly see, this is my speed rate. If you didn't know about your speed rate, if it was a total blank, you probably would either drive a bit too slow or way too fast. So the speed rate in your car is constantly visible, because then it helps you keep track of that. And then you do something about that, or you can put it on cruise control, which is just way easier and more relaxed. So it's a catalyst for sustainable engineering. Once you have this in place, there's stuff that you want to do, right? So you have it visible, and what's the next thing that you do? Well, turn shit off. Really. No, really. Because, as I mentioned earlier, we're wasting a lot of resources. And for example, if you work in the Netherlands, right? So say, for example, you work from 8 till 5, which is already quite long, depending on how you take your breaks. Most office applications, like back office, their peak moments are during the day. And if you are a developer, how many test environments does your department have? Probably more than your production environments. At least that's what my experience is. Do you need them after 7 o'clock in the evening? Can you turn them off? I know actually Rabobank does this, by the way. So I see people from Rabobank in the front. I know that they do that on parts of it. But you can do that everywhere. At least scale it down. Yeah? So if you have the ability to scale stuff down in the evening, or even turn it off, and then in the morning, make sure that you are able to turn it on again. And especially also in the weekends. And how much time would you save? Well, let's say, for example, the weekend, which is 48 hours, and then 5 weekdays times, well, let's say 12-ish. How many hours? I mean, that's energy saved, that's cost saved. A lot of stuff that you can gain there. So apply elasticity, which is auto-scaling. Yeah? So not just during the evening. Yeah? So, okay, I'm going to turn this off, but also based on demand. Scale it up when necessary, but also scale it down when it's no longer necessary. And I put light switch operations there, which is a term coined by Holly Cummins. She's a Java champion working for Red Hat. She talks about this a lot as well. So I like the phrase a lot, because why does she call this light switch operations? If you are in your home and say, for example, it's night and you say, I'm going to bed, you walk into your bedroom, you turn on the light. Probably none of you is sweating like, oh, I don't know if the light will come on. I mean, that's just natural for us, right? It's not that similar with IT systems. I mean, my laptop will probably start when I press the button. These big servers, big systems, especially the ones running for 20 plus years, we're pretty scared that they're not coming up again. So, and if you're scared to turn them on, I mean, you're basically praying to the server gods or whatever you're praying to. If that is what you have to do, you're not going to turn it off. So that's why Walle says light switch operations. If you make it easy to turn stuff on, yes, it's also easier to turn it off because you're not scared anymore. And this is, I think, our hardest hurdle with turning stuff off. And also, if you're looking at elasticity, it should be fast. Well, then she goes on to promoting Quarkus. Well, that's not what I'm going to do. But because that's specifically Java and there is other languages, but things should be easy to turn on because then you're not scared to turn them off. Right size your infrastructure. And yes, I'm looking at you, Kubernetes. It is something we tend to do because it's hard to guess, right? So we need to keep an eye on, do I right size? Am I requesting too much? Am I requesting too little? Because then you're being throttled, which is also bad. So you need to keep an eye on that. And so there's also tricks with, again, scaling, horizontal, vertical, but it's something that you need to keep in mind. You really need to take a look at what kind of resources am I using, and not only if you're using too much, but also if you're using too little, or requesting too little. I'm saying it slightly wrong. So right size your infrastructure, because I think we can gain a lot here by reducing the waste. And yes, build more efficient systems, or as I say it here, build less crappy software. And again, I'm not blaming any of you. I do this, or I try to do it less. I try to build less crappy software. But by nature, it works, right? And some of us learned, make it work, make it better, make it fast. But we tend to forget that last part. And I think that is something that observability really plays nice into. So the N+1 problem is something to look at, but there's more. Like if you're looking at your front end, well, front end development is by nature, I think, not that sustainable. npm install equals downloading the internet. That's it's easy to make fun of front end developers, but because Maven is not that much better, and the other dependency systems aren't that much better. Which is also something you can take a look at, right? So dependencies. And again, there is extra benefits, right? So I mentioned this earlier. It is not about sustainability only. You can save euros. A lot of euros, actually. I mean, 21% of, what was it, 500 billion? What could you do with that? Nice. And if you build less crappy systems or more efficient systems, there's quite big UX benefit as well. Was the previous client of mine. We noticed that something was always slow, but it didn't have priority. And then you introduced observability, the problem, something that persisted for years. Yeah, there's other things important, but then it was immediately visible what the problem was, and it was fixed in about an hour, right? So, because you don't look at if you don't look at the data, if you don't use it or you don't have it, you can't fix it. There is one thing I want to add here, and that's context, right? So if you're only looking at metrics, and for example, Excel sheets, and that's let's say, your whole world, and you're not looking at the bigger picture, then you're becoming entirely data driven. Yeah, there's always a story attached to metrics, right? So for example, if you're looking at a mission critical system which has a hot standby, yes, the hot standby has a utilization of, well, 3%. And then you're saying, yes, looking at the metrics, we should turn this off. Yes, and then if you do that, if that's your reason of thought, you turn it off. The next day, hey, we need to swap over. Oh, wait, we can't. And then, well, for companies like Rabobank, Dutch Railways, other big companies, they're in the news because, hey, there is a failure at your systems. So there is always context and a story attached to metrics. So don't rely solely on what you see in the data. Always look for the bigger picture. And I really like this one because, yeah, this is so obvious. I actually love these comics. They're awesome. They make fun of Agile, so yeah. Or at least not specifically Agile, but mostly the Agile with a big A. Which is quite funny. So that leaves me almost till the end. And the only thing I can ask you, what are you going to improve tomorrow? So are you going to add your metrics or even looking at your metrics? Because having the metrics is one, using them is two. And have your conversations with your team, your department, product owners. And the business case for doing this is, well, I think looking at the waste percentages, your companies can save a lot of money and in the meantime also be better for nature. So, that's all I have to say. And thank you for your attention, and please rate my session in the app if you have it. Are there any questions up front?
Are there some good ways to make developers more aware of making productive code? Are there tools that they can use locally?
Yes, well, if you're talking about, let's first repeat the question. So are there good tools to make developers more aware? Yes, there is, for example, a plugin for IntelliJ right now, where you can actually, it's called the, yeah, it's indeed TEQnation, which you can actually add to, for example, IntelliJ. You can run your tests with that enabled, and you have observability inside your IDE. So traces, metrics, everything. So that's something you can do. There is a plugin for Sonar, which is called ecological. It is, I know, tried that. It is, I mean, it's the little bits that help, but I think mostly it's using the dashboards in production and making them visible, talk about them, and then use those. TEQnation, right? Yeah, TEQnation, that's the one. Yeah, now I know it. I haven't used it myself yet. Saw videos about it. It sounds promising. Because then, it's sort of shift left for observability, right? So where you can, and there's other tools, right? But more specialized, like for example, the N+1 problem in JPA, so Java. There is a tool. I'm not sure. Well, yeah, I would have to Google for that. That can detect that if it might be configured wrong. And so these tools are usually aimed at performance. But better performance, if applied right, could also be using less resources and thus more sustainable. So a lot of stuff goes hand in hand. Other questions? See then one over here.
Yeah, you said
Yep.
Would the alternative be more wasteful?
Yeah, definitely. So the thing with going cloud native is that we tend to oversize, right? So we want to have the Aston Martin while a Fiat Punto would do. That's our problem. We tend to overestimate what we need. And then, okay, yeah, but we need 2 instances, and both of them wasteful. And so, yes, the alternative would be worse, because then you don't have any options to scale, because then you have this big monolith that's, yeah, it takes 48 gigabytes of memory, and that's the only way to do it. So yeah, the alternative is more wasteful. Going cloud native gives us more options to reduce. So yeah, true. Other questions? All right, then I thank you for your attention and being here. There's more sustainable talks today. Please visit them and help, make a better world in IT.